Hi scholars. Today we're going to talk about reference angles, especially on a unit circle. But this has to do with the Cartesian coordinate. So just as a reminder, we're talking about the x and y coordinates. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We're going to call the positive direction counterclockwise if we want to do angle measurement. And if we do angle measurement the other direction, we're going to call that a negative. So we're talking today about what we call reference angles. There's an actual definition. And the definition of a reference angle is the angle between the terminal ray and the closest part of the x-axis. So as far as vocabulary goes, remember terminal ray is if I have an angle here where it starts at the origin, this is my initial side, then let's say for instance I have 80 degrees. This is 0 and this is 90. So 80 degrees would be right around here, because from here to here is 80 degrees. And this is my terminal ray. That means there's also another angle here, closer to the x-axis, but that's 100. 80 is less than 100, so the reference angle will be 80. We're going to do a few examples. Hopefully it'll be a little clearer. Let's say we have 30 degrees. I draw a little axis. I start with my initial ray here. 30 degrees is going to be like here. And so I would say the reference angle is the angle between the terminal ray and the closest part of the x-axis. Well, this is the other angle closest to the x-axis, but that's 150. So the reference angle for 30 degrees is 30 degrees. Kind of a simplistic example. Let's say I want to do 140 degrees. Then if I draw 140, again I'm going to start on my initial side, 0. I go up to 90. It's going to be less than, so 140 is 50 past 90, so it's going to be somewhere like here. So this angle is 140. And then the other side of it here is going to be 40 degrees. So we're actually going to call the reference angle 40 degrees. The reference angle of 140 is 40 degrees because that's closest to the x-axis. Here's another one. Let's say we're going to do 280 degrees. Here's my axis. I start on my initial ray, so I go up to 90, 180, 270. Just past that is going to be where 280 is, so this here is 280. Well, I want to know what's the difference between here. Well, we know this is 270, so that makes this 10. And we know that's perpendicular, so that's going to make this 80 degrees. So the reference angle for 280 is 80 degrees. Again, it's the angle between the terminal ray and the closest part of the x-axis. Another example. Let's say I want to do negative 160. We haven't done any negative. I'm going to start here. Here's my initial ray. I'm going to go this direction instead. That's down. So here's 90. Here's 180. So it's going to be 70 past here, which will be, basically here. Not quite. That means this is 160. And so to get to the x-axis is going to be another 20. And so my reference angle is 20 degrees. Here's one that's a little tricky. What about 90 degrees? Have you ever thought about that? Here's my initial ray. Here is my terminal ray. Well, which side is closer to the x-axis? Either one. They're both. They're both exactly 90 away. So the reference angle for 90 degrees is just 90 degrees. That's it. One more example. Since we've been using pi's, and we know that all the way around is 2 pi, what if I want to know where, let's say, 5 pi over 6 is? Well, I have to think about this in terms of pi. So I'm going to label this as 0 pi. This is 1 pi. This is pi over 2, because it's half. And this is 3 pi over 2. Now you can look at the unit circle foldable for those, but you'll notice that from 0 to pi, if I divided this up into 6 parts, 1, 2, 3, 4, 5, 6, and I counted 1, 2, 3, 4, 5, then this is where, here's my initial, here's my terminal. So the only difference is that now we're in pi's, and 1 pi is like 6 pi over 6. So that means what's the difference here? This angle is going to be pi over 6. Okay? It's just slightly different because we're getting used to that. But 6 pi minus 5 pi over 6 equals pi over 6. So pi over 6 is the reference angle for that one. And last example. Let's say we have 7 pi over 4 radians. And we want to know what the reference angle is. Well, okay. Let's start. Here is our initial. Okay. If we broke up this quadrant system into fourths, let's think about this for a second. This is pi over 2, and this is pi. So if we wanted to do fourths, that's going to be exactly in the middle here, pi over 4. And this is going to be in between, so 3 pi over 4. That's going to be 4 pi over 4. This will be 5 pi over 4. 6 pi over 4. So this right here is 7 pi over 4. That means this is my terminal ray, and my reference angle is going to be pi over 4. You just kind of got to figure out where it is. And we'll be using this terminology, reference angle. For right now, your job is to put it in your notes. And then the next assignment, we will be using this terminology. So that's why this is 10 minutes on reference angles.